Hi, my name is Andy Dillon and this is Dave Hogg from, we're both from FM Services Group. We're just making a quick video because we've been asked to about the ConduDisc. Obviously we are EV installers and we install many commercial EVs, not so much domestic but more commercial. And what we found coming onto a lot of commercial sites, we can't get sufficient earth readings. So as a result, we've found a new product called ConduDisc, which is here on the floor. This is a composite product which actually you can bury in the ground at 450mm and actually will reduce your earth reading. Now we have actually done a few of these where we've not really spoken through what it actually does and how you install it. So we thought today we'd actually do that. But the key reason for doing this was because Dave, our QA, has actually taken some readings on their trowel and actually found that the readings were insufficient. We need to get below 100 ohms, and at the moment I think we're sitting circa 350 to 400, which isn't really adequate for what we need. No. I mean, I don't know if you want to go into a little bit more detail about that.
Yeah, basically, like you say, we need to get the earth reading because we're using an external earthing system below the 100 ohms. We've tried an earth rod, came in, what, about 200 was it?
Yeah, 350 I think it was.
I think 350.
I mean, I think the final reading was 250, but the initial reading was 350, so we've got down to 250.
Okay, and through experience we've had it before where we actually used an earth rod and it came back with some like 800 ohms. Put in the ConduDisc and we got it down to about 70. Which is obviously
I think the final reading on that side as well was 56 for a finish as well. So I think the thing with the ConduDisc, the more it gets embedded into the ground over time, because the earth packing and moisture and various different things that happen with the ConduDisc, as a result the earth reading keeps reducing. At some point it will stabilise, but initially on leaving site I think we're running at 56 ohms, which is pretty good from 800. And the difference between that is using an earth rod. For us is a massive problem because there are many other services. I mean, you probably won't be able to see the severity of the work or the complexity of the work we've done here, but we've dug 30 metres of trenching at 450mm deep to meet the requirements, and actually as a result we could have bumped in, unfortunately for us we didn't, but we could have bumped into pipe work, fibre optics, gas, water. The list is endless. I mean, and if you bump into one of these you're going to have a pretty significant issue. So what we've done, obviously we've worked with the guys from Earthing Services and they introduced us to this product and we found it's absolutely fantastic. So we're looking to get a reading well under 100 ohms at the end of this exercise. So what we've got to do here, we're going to dig out this hole. We're not going to video that because it's a bit boring. So we're going to dig a hole out, drop it 450. We'll show you what we're doing as we build it back up, and potentially, unfortunately at this stage, I don't think we'll be able to get any earth readings because we need a live feed.
First,
so we'll get it powered up and we'll do an earth reading at the end of it. Unfortunately, we haven't got any power here at this moment in time to allow us to do that. But ultimately, at the end of the day, this product is a bit of a lifesaver for us. It's a golden nugget because, as I meant to say earlier on, is that by trying to get a reading down to below 100 ohms, you'll be using 3 or 4 earth stakes potentially. Now you also have to take into account wherever you are in the country. We're national installers, so we install all over the country, and actually resistance readings vary from site to site. Earthing Services can also help with this, but there are websites that will tell you this, so you know what your resistance problems are likely to be when you get into those regions. We're in the Birmingham area today. We think the resistance readings should be pretty good per se, but we'll know once we've got the plate into the ground. But again, 1 plate instead of 5 rods, massive difference, minimising the risk. We know in this area here we can get down to 450mm without getting involved in anything. We don't know that we can get to 1 metre because we know there's pipe work below here, but we don't know how deep it is.
Yeah, no, definitely, and that's obviously the main problem when you're using an earth rod. You really don't know what's down there. And as you're actually just whacking it in, you're not able to do it kind of gently to see what is down there. Whereas with this, we can kind of excavate slowly, make sure there's nothing in the way. So yeah, I definitely do that.
Essentially, so pretty much we're going to go and dig out a hole now. Once we've got the hole dug out at 450mm, we're actually going to come back to you and give you a quick heads up of the hole, plate in the ground and show you how we build back from that scenario there. We also use another product to actually go with the concrete. We'll show you that as we put it back together. So yeah, we'll cut and we'll be back to you very shortly with the next stage of how we put it all back together. Yeah, so we're just reporting back to you now on what we've done there. So far we've actually dug a 485mm hole in the ground, which is to accommodate the 45mm of ConduDisc, actually allowing for circa 400 to 430 mil depth in the ground, which is what we need to meet according to earthing services. So what we're going to do now, we're going to quickly go through, if we just bring Rob in, it's another member of our team. So Rob is our apprentice electrician, not for much longer by the way, he's qualified in June. We're all electricians. So Dave, the QA, obviously, he's more qualified than all of us, and he's got more time served than himself and Rob. Rob's qualified in June. I'm pretty much just a little bit ahead of them, not much, 6 months I think. So I'm sort of managing director of the company, and so my job is to obviously work on the team, so these guys work with other stuff. I do a lot of groundworks, that's my sort of expertise, and technology is also my thing, so data cables, fibre optics, that's what I do. So, but I understand what these guys are doing as electricians. So, as it stands now, we've dug a 450 mil hole in the ground, and we're now going to put the ConduDisc in. This is the ConduDisc, as we showed you before. That is just going to get buried in the ground, but to bury this we can't just simply put it in the ground. Technically you could, and actually it would still do the job, actually, but to make sure we create the best conductivity we can, we're going to use something called ConduCrete, which is also a product of the same company. So it is a very much cement-like. It's pretty much a cement, but it's a very special cement. It's not just a regular old cement. So we're going to drop this in the bottom of the base to start off with. Sorry there, Rob. Cover you in the so we're going to put a bit of ConduCrete in the bottom. Start off with, that's it. And then we don't need, on a previous video I did with this, I actually stamped it into the ground. You don't need to do that, I was advised. So we just simply put it into the ground, just to pat it down. We're not going to go crash, we're not trying to crush it into the ground. We're just trying to get a level base to put the disc on. So pop the disc into the ground. Yeah, don't go too mad because we don't want to create too much dust either. That'll do. So from there, we've actually got it buried in the ground. I don't know if you just want to get in and have a quick look at the camera and see what we've done. It's nothing more than a 485mm hole in the ground. We're now filling it with ConduCrete, and we're now going to put the ConduDisc into the ground. And just for the well-being, we'll just level that up, make sure we get it as flat as possible. Just for the sake of it, I'm going to stand on it for the hell of it, just to make sure it's flattened out. Nothing, you know, we're covered in mess anyway, so it won't make any difference. I'm quite happy with that, it's not perfectly flat. That's it. So we're just going to quickly stand on with this. So, just a quick recap. So ultimately, Dave, why did we get to this?
We got to this, basically, we're installing some EV charging points, need to use the external earth. We tried using an earth rod, got a very high reading, 350, something like that.
Yep.
So to get our readings lower, we're using what's called a ConduDisc, where, as Andy said, we dig down 450,
Yep.
put the disc in, earthing up. We've used it previously on a few occasions where, in particular on one, we had a reading on an earth stake of about 800.
Yeah, 800
got it down
off
to
a single stake.
Off a single stake, got it down to under 100, 50, 60 in the end.
Yeah.
So that's essentially why we're using it now. So
I think a couple of things just to add in there. The reason that we also use the ConduDisc is because we only do commercial installations, and as a result of doing that, if we are putting in this case, we're putting in two Garrow GTB dual socket outlets, so 63 amps, that's 126 amps of charging. We would have to use two transformers or some sort of PME devices, but not one of. You'd have to use one for each charger. Well, actually, when you start racking that up, that cost is significant. When you're looking at this, you're talking about £235. We can connect up 4 chargers to this and still maintain that stability. Also, when we talk about stability, we're talking about single point of failure. Now, as a technology guy, my background is IT. Okay, so from a technology point, we always work on a single point of failure. So when it comes to the client interacting, it's all about the design. So actually, we put isolators in so that if the client has to go back, he only has to go to the isolator, rotate the isolator, turn it back on, and in most cases that's enough to restart it. We shouldn't really be engaging clients in resetting RCBs and everything else. What you tend to find with these transformers or PME devices is that they have to reset the PME device, then reset the charger, then the list starts to go on. So this is coming down to a single point of failure. So they literally, if it's an RCB at the charger, it can be done in 30 seconds. If it is actually just a rotator, power it on and recycle it, the client can go to a rotary isolator, which meets the criteria of the IET and the regs, turn it off, turn it back on, and it's a recycle. If it doesn't work, then you've got to call us out. That's what we're there for. That's what we're there to do. So from here now, just to carry on about ConduDisc, we digressed a little bit. So just to carry on with this now, we've got that in. So now what we're going to do is we have to put earth on top of this now. So we're going to backfill this with some earth. We're going to put it back in the ground because we've got to rebuild this. Because the important part about this is as well, because the excavation side of what we do, this is a walkway. So it's high integrity, so we have to pack it down with different types of material, MOT, gravel, ballast, and actually to make sure that the walkway doesn't sink over a period of time. So we are backfilling in this case in a different way. If you're doing a grassed area, you wouldn't have to worry yourself too much about that scenario. So from here, we're going to backfill from this side. And this is a sort of very rudimentary sort of installation. There isn't anything aesthetic about it. It's literally meeting the criteria to get the earth reading. So in there, thanks for just jumping the hole again, just make right bet you see, just stamp it down. That's in, that's levelled off. Now we're going to add some more concrete. Back it on the top again. The reason to put more concrete in is to actually try to create get better resistance, and over time as this dampens out and actually builds, it will make a solid base connectivity between the ground, the ConduDisc, and then the earth in between. Now we're going to backfill this right up to the level that we want with earth, and the game's over, all done and dusted. It's as simple as that. So we'll just backfill this right just to quickly show you. So, in a nutshell, that is it. Now we're going to build this back up so obviously we can lay our patio and slabs and get everything back as it should be. And obviously we've got still got a bit of groundwork to do over there to finish the charger off. We'll give you a full images of the actual completed job as it's done, and we'll also give you some readings from our Mega and put that up and just show you what kind of resistance we get. Again, to conclude, for me it's a golden nugget. It's actually, although some people may argue the issue of civils and not being able to do that work, we're in the fortunate position where we do all our work ourselves, so we do our civils, and for us this is much quicker than actually Dave, Rob and myself potentially trying to wire up 3 matty boxes to service 3 chargers. It's almost pointless in my opinion. I don't know what you think.
No, I agree totally. Yeah.
And Rob actually wires most of these chargers up as well. So I mean, from your point of view, this is a bit of a time saver, I would say.
It's more convenient.
Yeah. So you know that's our opinion. You know we've got other team members as well. We'll bring in over the next couple of videos we do to show you what kind of other stuff we do, because we go a lot deeper than this, and we'll take into full installation what happens from MCCBs straight through to EVDBs, which we create, and rotary isolators to actually do end to end. This is a commercial installation. This is not what you would do for a domestic. Okay, so that's pretty much the installation completed. Don't forget to like and subscribe, and we'll see you on the next one.